Now I'm going to take a look at yet another proof. In this example, I am told that angle 1 and 4 are complementary. Notice 1 and 4 are not together. They're not forming a right angle. Visually, it's going to be a little bit harder to follow this. Angle 2 and 3 are also complementary. Again, they're not actually shown forming a right angle, which means we're going to have to do a little bit more work from a visualization standpoint to make sure we understand what we're doing here. You also notice that RT bisects angle SRV. Okay? This is not a double bisector statement. This is just saying that one angle is being bisected. Probably I'm not going to be using one of the properties that talks about bisecting two things and getting two congruent segments or angles. Probably I'm just going to be using the base definition of a bisector, that it cuts an angle into two congruent angles. So again, unless I see a double pairing of a bisector statement, probably just coming back to that root definition. So the other thing I want to look at anytime I do a two-column proof is, what do I need to prove? And you'll notice here that I'm trying to prove that angle STV, the angle on the other side, is being bisected. So just because RT is bisecting angle SRV doesn't necessarily mean that it bisects the angle on the other side unless we have certain components coming together. So that's what we're going to be trying to show in the proof here. When I take a look at this, I always think about what I need to show. If I'm going to show that angle STV is being bisected, my goal is to show that angle 1 is congruent to angle 2. If I can show those two angles are congruent to each other, I'm going to be able to show that the angle has been bisected. It's been broken into congruent parts, so we can say it's been bisected. That's going to be what I'm shooting to do. So always make sure you look at that prove statement. You don't want to go off in the wrong direction and show something that wasn't required as part of the proof. So let's take a look at this. I have double complementary statements here. And very typically throughout this chapter, when we've seen double complementary statements, we've had situations where angles have been complementary to congruent angles or where they've been complementary to the same angle. I'm trying to show that 1 and 2 are congruent. It would be really nice if I could show that angle 4 and angle 3 are congruent to each other. Then I could show that 1 and 2 are complementary to congruent angles. Well, not sure how to do that. I'm going to go ahead and take a look at the rest of the given statements, see if that gives me any additional insight. And you'll notice here that RT bisects angle SRV. When an angle is bisected, it's divided into two congruent angles. These two angles are going to be congruent, which are exactly what I was trying to prove congruent up there when I first noticed those complementary statements. So, I need to use that given statement to get that result. SRV is being bisected, so angle 3 is going to be congruent to angle 4. And the reason being, if an angle is bisected, it's divided into two congruent angles. So, got that information done. 3 and 4 congruent to each other. I'm going to mark that 3 and 4 are congruent to each other. Now that I've shown that these two angles are congruent to each other, I already have two pairs of complementary angles. I've shown that they're both complementary to angles that are congruent. At this point, I should be able to say that angle 1 and 2 are congruent because they're complementary to congruent angles. So, step 5, angle 1 is congruent to angle 2. Reason being, if angles are complementary to congruent angles, we can say that those original angles are congruent. And we are almost done. I've shown angle 1 congruent to angle 2. Remember, I was supposed to show that angle STV was being bisected. I've shown it's broken into congruent angles. One final step. All I need to do is make that statement that the angle has been bisected. We can say that TR bisects angle STV, and the reason being that ray is dividing it into two congruent angles. Be very careful when you're writing that statement. You don't want to write the converse of the statement. You need the if part to be based on information that's already been shown. You need the then part to match your conclusion. So, I have congruent angles. I want to conclude that it tells me that that angle has been bisected. So, if a ray divides an angle into two congruent angles, then it bisects the angle. At the end, you always want to check, make sure your if-then statements match up with information that's already been shown in previous steps. We talk about an angle being bisected. That's been shown already, so we're allowed to conclude that it's broken into congruent angles. Here, if angles are complementary to congruent angles, we've shown previously that they're congruent, then we're allowed to conclude that those angles are congruent. We talk about a ray dividing an angle into two congruent angles. And again, we've shown that those two angles are congruent, so we're allowed to make the conclusion that the angle's been bisected. That is how you can set up this proof.